So the next problem which we have is also a very good problem, as it involves the concepts of nth roots of unity. We need to prove that all the complex numbers z which are satisfying the given expression z power n is equal to z plus 1 power n, they lie on a line which is parallel to the imaginary axis, that is the y-axis. In order to solve this problem, we try to concentrate on this expression, z power n is equal to z plus 1 power n. This can be rewritten as z plus 1 upon z whole power n equals 1, or 1 plus 1 upon z is equal to 1 power 1 upon n, that is a cube root of, or rather a nth root of unity. And we know that any nth root of unity can be represented in the form of cos of 2k pi by n plus iota times sine of 2k pi by n, k attaining the values 1, 2, 3 up till n minus 1. So 1 upon z can be written as cos of 2k pi by n minus 1, writing the two real parts together, plus iota times sine of 2k pi by n. This can be further simplified as 1 upon z is equal to, this can be written as 1 minus 2 sine square k pi by n. The 1 and 1 get cancelled out, hence this becomes minus 2 times sine square k pi by n. And similarly it can also be written as 2 iota times sine k pi by n cos k pi by n. We have converted the double angles into single angles. So this becomes 2 iota sine k pi by n. We try to make the cos k pi by n term as the real term. So this becomes plus iota times sine k pi by n. This is an entire constant thing. So we can write it as 1 upon z is equal to some constant k dash into e power iota k pi by n. So z can be written as a constant k double dash into e power minus iota k pi by n, or rather k double dash is 1 upon k dash. This becomes k dash was 1 upon 2 iota sine k pi by n into e power minus iota k pi by n can be written as cos of k pi by n. Since cos of a negative angle is equal to positive angle, cos of the positive angle, minus iota times sine of k pi by n. This can be further written as cot of k pi by n upon 2 iota minus half. This is the value of z. This can be further written as minus half minus iota times cot k pi by n by 2. Now writing it as x plus iota y, we see x is equal to minus half and y is equal to minus cot k pi by n by 2. Very clearly x equals minus half, that is z is lying on a line which is parallel to the imaginary axis, because x equals minus half is a line parallel to the y axis. Hence we have proved the required result.